Okay, so we're going to look at a simulation here, an example, and this example is in Bach's textbook. But if you don't have your book, this is a really, really good example to check out and watch the video. So we're basically going to run through how to set up a simulation. So I've got this scenario where I'm buying boxes of cereal and there's some sort of prize in the cereal. So sort of a silly situation, but kind of a difficult question to answer, which is if there's different chances to getting each of these sports cards corresponding to the different sports figures. There's not just a 33.3% chance of getting the Roger Federer, the LeBron James, and the Tom Brady card. There's a 20% chance to get Roger Federer, 30% chance to get the LeBron James card, and a 50% chance to get the Tom Brady card. So we want to figure out how many boxes of cereal we need to open in order to get all three. So we're going to pick random numbers to correspond to the outcomes, then look at those random numbers and simulate sort of how many boxes of cereal we would need to open. So the key is that we're going to use the percentages here to correspond to our random numbers. So each random number is going to correspond to and be a component. So a component in the simulation is going to be a single random digit that corresponds to what card you got out of your cereal. So that's which sports card was in the box. So how will we model the situation? Well, let's make the digits 20% chance that we get a Roger Federer card. So how about the digits 00 up to, I was going to say 00 up to 19, but we don't. Make this easier, I'm going to go 1 to 20 corresponds to getting a Federer card in the cereal box. 21 to 50 corresponds to getting a LeBron James. And 51 to 100 corresponds to getting a Tom Brady. So I've got to use the percentages, the likelihood of something happening, that I have to match that up with the specific random digits. And obviously when this is all done, I should have 100%. So explain how I'm going to simulate the trials. So I'm going to do rand int 1, 100 on my calculator. That's going to give me a random number between 1 and 100. And I'm going to pick random numbers and then write down what sports card that would correspond to in the box of cereal. And I'm going to do that until I get one of each athlete, and then that's going to constitute a trial. So I'm going to pick random numbers. In this case, duplicates are fine. Until we get one number between 1 and 20, one between 21 and 50, and one between 51, and 100. And the response variable here is how many boxes in total did we need to open. So how many random numbers did we need to pick until we get the 3 random numbers that I talked about in number 3. We need to get one number between 1 and 20 that corresponds to getting a fetter, one between 21 and 50, and one number between 51 and 100. We're going to keep picking the random numbers, the random integers, until that happens, and we're going to count how many random integers it took. So the response variable is how many boxes do we need to open to get one card of each celebrity. So now we're going to actually run some trials. So I've got my calculator right next to me. I did random integer. So I go math, PRB, random integer, 1, 100. And my outcomes were, I'll write them down. I got a 5, a 34, and 100. That was quick, because if I scroll up here, that 5 corresponds to getting a fetter, that for 34 corresponds to getting a James, and the 100 corresponds to getting a Tom Brady, and I'm done. It took me 3 boxes of cereal to get each of the 3 athletes. So that was trial number 1. So for trial number 2, I got a 21, I got an 80.
I'm gonna go outside to cough.
So I got a 96, I got a 23. So far here, I've got, the first card was a James, then I got a Brady, another James. So I need to keep doing this until I get a number between 1 and 20, which would correspond to getting a fetter, and there I got it. So it took 1, 2, 3, 4, 5, 6 boxes. Trial 3. I got a Brady, I got a fetter, I got another fetter, I got another Brady, I got another Brady, James. 1, 2, 3, 4, 5, 6, 7 boxes. And I'll run one more trial. That's a James, fetter again, Brady. So I ran 4 trials there, and the number of boxes was 3, 6, 7, and 4, so I always want to compute the average number of boxes it took. So the average number of boxes it took would be 3 plus 6 plus 7 plus 4 divided by 4. Would be 5. So on average, I had to open up 5 boxes. Now, 5 boxes of cereal to get 1 card of each athlete. Now notice though is that I only ran 4 trials of this simulation. If I wanted to be really sure, I would run 20 trials. Now, that would obviously get a little bit tedious. I would never ask you on a test to run, say, 20 trials, so I would just get really old really fast. But when we do this in class, I mean, if each group runs 5 or 10 trials, and when we combine our results, we'll actually have a lot of trials. And that'll give us a more accurate picture of how many boxes of cereals we would probably need to open. Because we could look at the distribution of all the trials, and we could see like if there was any outliers. Like for example, I mean, you could have to open 700 boxes of cereal before getting 1 card for each athlete, but that would probably be really, really, really unlikely. So we want to identify in our distribution if there's any outliers. So now, the last question here, analyze the response variable. Was kind of already talking about that, in the sense that on average it took us 5 boxes of cereal to collect 1 card of each athlete. So I'm gonna write that in the stating my conclusion. So on average, our simulation showed that we needed 5 boxes of cereal to get 1 of each card. In the analyze, like I said, was on the slide before, I found the average to be 5 boxes of cereal. The average of all my trials, and then I could write a little sentence, tell a little story about what I learned from the simulation. So obviously this gives us an idea of how many boxes of cereal we need to open, and it's less tedious and more cost effective than actually going to the store and buying a bunch of boxes of cereal and ripping them open. So we can use this kind of as a guide for when we're doing our own simulations, kind of what to talk about, defining variables, and properly explaining what random digits correspond to what events happening. So good luck. Okay, so we're going to look at a little bit of a tougher example here. And you probably have it on your worksheet, but I don't have it on mine. So I'll just have to I'll say the problem and kind of sketch out the key details. So I have, apparently, the problem is about Mr. Strader, which is me. I have 10 gray suits. In my closet. Great. And so we've got a bunch of these probabilities of when I'm going to wear a gray suit. So on Monday, there's a 28% chance that I wear a gray suit. So on Monday, there's a 28% chance that I wear a gray suit. Great, but then the problem gets a little bit tricky because then I break into 2 scenarios. So if I wear gray on Monday, so that's the key there. It's if we wear gray on Monday, then there's a 40% chance on any other day to wear a gray suit. So that's only if I wear a gray suit on Monday. 40% chance on any other day to wear a gray suit. But if I don't wear a gray suit on Monday, so if I'm not wearing a gray suit on Monday, then there's a 70% chance on any other day to wear gray. So, pardon me for the sentence fragments and all this, but I just wanted to sketch out the problem, which you probably have on your worksheet here. So that's sort of the scenario. So now I need to sketch out sort of my possibilities here. So let's see how I'm going to label these random numbers. So that means that 1 to 28 is going to represent gray on Monday, and 29 to 100 is going to represent not gray on Monday. But then depending on what that Monday is, that's going to change the numbers for the rest of the week. So if I'm not gray on Monday, or rather I'll do it, which way did I have it here? If I'm gray on Monday, so 1 to 40 is going to represent gray. 41 to 100 is going to represent not gray. That's only the scenario if I wore a gray suit on Monday. Now, if I didn't wear a gray suit on Monday, then for all the rest of the days, 1 to 70 is going to represent gray, and 71 to 100 is going to represent not gray. So that's if I did not wear a gray suit on Monday. So the basically is I have to figure out what happens on Monday first, and then if I landed in 1 to 28 on Monday, I'm going to use these numbers right here for the rest of the week. And if I landed in 29 to 100, I'm going to use those numbers for the rest of the week. And I want to run a couple of trials here. So a trial consists of running the entire week, and my response variable is how many gray suits did I wear in that week. So I'll run a trial. So I'm going to pick 5 numbers from 1 to 100 at random. I'm using the calculator, randint, 1 to 100. And my 5 numbers are 2, 43, 31, 98, and 3. Those are my 5 numbers, corresponding to Monday, Tuesday, Wednesday, Thursday, Friday. So now let's look at these numbers. So on Monday I got a 2. That means that I wore a gray suit on Monday. Now, since I wore the gray suit on Monday, I'm going to be using those numbers right there that I just starred. So that means on Tuesday, 43, so that corresponds to not a gray suit. Wednesday, 31, that corresponds to gray. Thursday, 98, corresponds to not gray, and Friday 3 corresponds to gray. So notice for the Tuesday, Wednesday, Thursday, Friday, I was using those guidelines for whether or not the suit that I was wearing was gray, because on Monday I wore a gray suit. So I can't stress this enough, if I wear a gray suit, then I'm using those numbers for the week. If I do not wear a gray suit, then I'm using the 1 to 70 represents gray, and the 71 to 100 represents not gray for the rest of the week. So let's look at another trial. So I got 84, 62, 21, 99, 73. So that means that on Monday, I'll label Monday, Tuesday, Wednesday, Thursday, Friday. So that means on Monday, I did not wear a gray suit because I got an 84. So that means I'm using those numbers, the 1 to 70 and the 71 to 100, those digit assignments for the rest of the week. So that means Tuesday, gray suit, because that's between 1 and 70. Wednesday, gray suit. Thursday, not gray. Friday, not gray. So I only got 2 gray suits. For the second week, the first week I got 3 gray suits. I could then continue running trials, and for all of my trials I could take the average number of gray suits that I'm wearing in a week, and I believe that's what the question is asking. So the question says, run and record 10 trials. I don't have enough space on this slide to do 10 trials. To determine on average how many gray suits that I would wear during the week. So it looks like for my 2 trials, I'm wearing on average 2.5 gray suits in a week. And remember, the average does not have to be a value that's realistic. It's just the average of all of your trials. So in a week, I can't wear 2.5 gray suits in any given week. That just makes sense. But the average for all of my trials here is 2.5 gray suits in a week. So the key to this is just being very careful with your random, with how you're assigning the digits to what events those are corresponding to, and then what's going to correspond a trial. So in this case, a trial was Monday, Tuesday, Wednesday, Thursday, Friday, the 5 days, and seeing how many gray suits I would wear in those 5 days. So good luck.